Welcome to another exercise in a workbook statistics. This time I'm going to talk about an exercise focusing on the so-called homogeneity test. So let's have a look at the exercise. A university has 3 campi where they offer bachelor and master programs. The share of students that cancel their studies are summarized in the table below. Here we get this information, shares for bachelors, shares for masters, and the 3 locations. Additionally, we know in total, in Düsseldorf, there are 500 students, in Berlin 800, and in Hanover 300 that are evenly distributed on bachelor and master programs. Our task now: use a suitable test to check whether significant differences exist between bachelor and master students. Consider that a margin of error of 5% is deemed acceptable. Well, here we're going to compare 2 different samples, the bachelor sample and the master sample. And whenever we want to do this and want to see whether they show a comparable distribution or have a common joint distribution which they follow, then we're going to use the so-called homogeneity chi-square test. For this, first off, we have to use these numbers to actually calculate absolute frequencies, absolute numbers, how many students are actually quitting their study programs. That's then the first task we did here. We calculated the absolute numbers by simply multiplying the overall number of students in each location with the shares of how many quit. Then we can also calculate, in addition, the sum of all bachelor students across all 3 locations that quit their studies and the sum of all master students. That's actually just preparation of the data we already have from the exercise text. The first real task is calculating the theoretical common distribution. That's something which we get by adding up bachelor and master numbers. So here 40 plus 45, so 85, and dividing this by the sum of the 2 sums. So 162 plus 157. So in this case, we get 219. So we divide this 85 by the 219, giving us 0.2665. And we're going to do this the same way here. We're going to add these numbers, giving us 156. We're going to divide this by the 219, giving us this value. And finally, the same with this one. So that's the common distribution. So under the assumption that they share a common distribution, that's how it would look like. However, we cannot work simply with the common distribution. We also need expected frequencies, expected absolute frequencies. And those we get by multiplying the common distribution with the sums, once for bachelors and once for masters. So we're going to add 2 additional columns here: the expected values for bachelors and the expected values for masters. So for the bachelors, we're going to multiply 0.2665 with 162, giving us this one. Then we're going with 0.489 times 162, giving us the 79 point something. And finally, 0.2445 times 162, giving us the 39.6. For the masters, we're going to multiply the 3 values here with the 157. So 0.2665 times 157 gives us here the 41.8405. So we're doing this for all 6 entries. And then for each of the 6 entries, we can compare actual value and expected value. And that's how we get our test statistic, our chi-square test statistic, by just using these chi-square comparisons on this data. Chi-square comparison, this means actual value minus expected value, corresponding expected value, in parentheses, squared divided by expected value. And that's something we're going to do for each of our 6 different entries. Here, I just wrote this down in one line. You could, to keep a better overview, also add 2 additional columns, like chi-squared bachelor, chi-squared masters, and then do the calculation for each entry by itself. Well, here Also, to see this in one line, I wrote this in this fashion. If we put this into a calculator, we get a value of 0.78. That's our test value. Now we're going to compare this test value to a reference value from the table. That's actually the next part we're going to determine. We're going to calculate or look up a reference value, which for the homogeneity test is always chi-squared I minus 1, 1 minus alpha. The I, that's the number of categories. Here we have 3 different categories. So we have 3 minus 1 giving us the 2. And we had a margin of error of 5%. That's the alpha. So we go 1 minus 0.05, the 5%, giving us 0.95. Then we're going to the table for the chi-square distribution and look this value up. There we find a value of 5.9915. So for the final test, we're just going to compare the test value from the previous slide with this reference value. And here we see that the reference value is definitely the larger one. Whenever the reference value is the larger one, we know we cannot reject our H0 hypothesis, so we have to keep this. And H0 for the homogeneity test means that both samples, both groups, share or follow the common distribution. So in our example, this means can be assured that no difference exists between bachelor and master programs regarding the students who quit their studies. Or rather, it cannot be assumed that they are different. And well, that concludes this exercise. This concludes this task. I hope you enjoyed it. I say goodbye and see you next time.